Okay, so today we talked more about position and time graphs and things like that. So uh, we determined that with the tumble buggy stuff here, when we had all these equations, um, that again the slope of the tumble buggy, I should say the slope of the tumble buggy graph, the position time graph, that is what we call velocity. Okay, it is the change in position over the change in time. The symbols we use for this, though, we have the Greek letter delta. Delta, which is a change in something, like delta means change. It's a symbol we use for change. And we're talking about position in x. Okay, so delta x and delta t. So that is what we call velocity, which is the slope of a position versus time graph. Now, I know I didn't have this up here last time, but this is what's happening, okay? We have a slope of a position versus time graph. That is what velocity is. Notice there's no definition here. I didn't give you like a word definition for what velocity is because it's right here. So velocity, if someone asks me what velocity is, I'm telling them it is the change in position over the change in time, or the change in position per unit time. You could say it that way, or delta x over delta t. That is what velocity is. And that is the slope of a position time graph. That's what that is. And that's what our slopes were for the lab, which were the velocities of our tumble buggies. Okay. Now, today in class, we talked about this. This was my data. This was my data for my tumble buggy when I took the data back several years ago, because I did this lab as well. And this is the data I got. And this does not look like your graph. So these do not look like the graphs that you got for your tumble buggies, but this is mine. So what's going on here? As you look at this graph, what is this saying to you about my data? I mean, if you look at the data table, at position 0, I was at position 0 3.3 seconds in to this whole thing. Position 0, 3.3 seconds in. My y-intercept that's big. Like it's 136.2 based on my little graphical analysis situation. So 136.2 centimeter y-intercept. I have a negative 41.2 slope. Clearly, this is a negative slope. So I hope you understand that positive slopes versus negative slopes. This is not like yours. So what happened? Well, if you think about how you wrote your equations and how the y-intercept was the position when time is 0. Again, when you look at the time at the bottom on the t-axis here and you go all the way to the left, that's time 0. That's when the clock started. Where was my buggy when the clock started? 136.2 centimeters apparently. Where was my buggy later on? Well, later on it got to 0. Well, how do you go from 136 to 0? Well, I'm glad you asked. Let's look at this situation here. 136 is about where I drew this line here on this track. So that's where my buggy was when the clock started. And then it got somehow to the 0 position, which means what's happening with my buggy? It's moving how? I hope you're thinking that it must be moving. Well, some people would say backward. I don't know if I would say backward. It's moving in the what direction? Well, you all had positive slopes, and yours was going like in the positive direction on the track here. Mine has a negative slope and it's going the other way. So mine started at 136. Actually, we started it at 135 centimeters. Now, my y-intercept in the equation says 136.2, which means my y-intercept is 1.2 centimeters away from where it really was. Like we really started our vehicle not at 0 position, but at 135 centimeters. And then we marked positions out every 15 centimeters until we got to 0. Oh, I thought it was going to start going. And then 3 seconds later, 3.3 seconds later, boom, it got to the 0. So my tumble buggy was going the other way compared to what yours was, which is why my slope is negative. So here's something to think about, and you'll want to write this down. The slope of the XT or position time graph, it's telling us two things, okay? How steep it is telling us the how fast part. Write this down. How steep. So how steep that line is on that graph, that's telling you how much position change you're getting every second. That's how fast. Which way it's tipped, positive or negative, that's telling you which direction the object is going. Mine was tipped negatively, which means mine's going in a negative direction. Yours was tipped positively, which means yours is going in the positive direction. I hope that makes sense. Is that making sense? And I'm probably pointing in the opposite direction of what, like to the right, like this is my right hand. And so this would be to the right for me. Is that to the right on my screen? That's to the left on the screen. I don't know, whatever. So anyway, mine was tipped the other way, opposite of yours, which means I had a negative slope, which means my buggy was traveling in the negative direction. Yours was traveling in the positive direction because you had a positive slope. Does that make sense? I hope it makes sense. This is critical here. This is critical. So the fact that the slope of the position time graph is what we call velocity, very important. And that slope is telling us two different things. That's telling us how fast with the steepness and what direction with which way it's tipped. I hope that makes sense. Those are like the big ideas from this lab and this whole unit is this idea and concept of velocity and how to use a position time graph to figure out what kind of motion is happening. So that's what we talked about today. Again, took a couple notes. These things need to be written down. And then I posted another assignment, which you will see. So this one here, which is, oh, that's not what I wanted. I want the, oh gosh, I'm in the way. Classwork. So this worksheet here then has been posted, and this is what you'll have to do. You'll answer these. You can sketch these graphs. There's page 1 and 2. You can sketch those graphs in your comp book. You don't have to, because you're staring right at them on the screen. But you need to answer the questions A through E, and then A through E for the two sides in your comp book, and then that's what you will upload a picture of. Okay, so that is for today. What we did today, I should say, for the next time we have class. So hopefully that makes sense, and the velocity stuff is making some sense for you, I hope. I think that's it. So, hey, take care of yourselves, and until next time, we'll see ya.